Hello and welcome back to the channel. It's Mark from PowerSonic and Apprentice 1-to-1. You might be able to see behind me here, we've got a new piece of kit on the wall. This is from Proteus. It's from their MC range, and we've got a molded case circuit breaker in there, 160 amp variety, and it's tied to a Type B RCD device. This one is a little bit different. I've not seen many people sharing content on YouTube around these kind of things, so I thought I would cover it in a few little videos. We're going to experiment and play around with this and show its uses and functions on three-phase circuits. But to start with, I thought we'd have a run through the installation. So I'm going to pop a little time lapse on and we'll show this coming together and how it's actually intended to be wired. Now, we do have some other content planned for this where we're going to show the case points where you might want to use these out in the real world and some examples of the circuits we're going to need to be protecting with those Type B RCDs at three-phase level. If you've not already, don't forget to subscribe to the channel so you don't miss those when they come along. And it helps us as well to spread what we're trying to do here as far and wide as possible. So I would really appreciate it. And as always, if you've got any questions or comments, drop them in below. I love the interaction with people, learn myself a lot of times through the course of this content, and hopefully that's going to be the case with this as well. But without any further ado, let's get on with the video and see how this got onto the wall. Let's get on with some actual work, and you can see first up we need to clear some space. This is full to the rafters and I'm going to strip out a lot of the gear we've got here, starting with the TV. We need to get these enclosures opened as well, so obviously we've isolated this power down to the area and it's all suitably locked off. So we've got these Schneider boards here, and this is where we had the power coming down into this area to then subdivide it and make use of this space for some testing and setting out containment. You see there's lots of stuff in the wall, so I'm going to take all this out and use the opportunity to have a bit of a cleanup. We've got bits of containment where we bridged over certain other obstructions and set out doing bubble sets and things. So we're going to take those spacer saddles away, or hospital saddles, and then we've got a bit of room to work with, get some of that conduit off the wall and put this new product into position. Bang the head there, if no one spotted that, that did hurt. So do take care in the area when you're working, make sure you're aware of obstructions. I'm going to pop this trunking open and see what we've got inside as well, and open all this up so we've got good access and make sure we've got space for what I'm intending to do. This trunking is pretty much empty because we've just got those two socket circuits sat through there. Leading off from that Schneider board, it is very sparse, so we're fortunate to have lots of room in there. And I'm going to show a couple of working methods around this when we get further on in the video to set out some of the common mistakes people make, and I've made them before when we're drilling into trunking or accessories, not taking consideration of some of the swarf and such that you might encounter. So we need a bush and coupler here, so we've got that to take the cables out of the trunking and into the new product that we're putting on the wall there. And I need to find my hole cutting set. See, that was in my bag. I'm going to sort out all my tools because they've all got massively mixed up of late, so making sure we get the right size. And then I need to find my drill, which is also hidden away down on the floor there. And that's the trouble when you are splitting your tools apart across so much stuff. So I do bits here at the academy and then out on site, and everything ends up everywhere, and with the best intentions it doesn't get put back where it should. So you can see here we've got a bit of cardboard in there just to collect any swarf that's going to spill through into the actual enclosure itself. And I did do a little short video explaining why you would want to do that and simulated a viewpoint that maybe showed me not doing it. And again, here with these cables in the trunking, I've tried to trigger some comments in other parts of social media by showing this been done without, could be termed due care of getting the cables out of the way. It doesn't really matter in this case because all these cables are dead and they're all coming out. But if you ever are making holes into containment, make sure you are protecting your existing cables and not drilling into them. You see here we've got our female nut on the inside here, so it's going to protect those threads from any snags rather than just using a normal fastener on the inside. So we're not going to snag any edges of the cables. It's probably pointless. It's not going to make a great deal of difference, but I had some there, so I thought, why not use it? It just covers all the threads inside the enclosure. You can use them the other way around as well, so if you wanted to, you could pop it up into the trunking. People work in different ways. Generally, I always try and have the threads inside the enclosures because that's where you're going to have less of the cables running across them. Whereas in the trunking, you'd have that obstruction in there getting in the way. And this way around, that doesn't happen. You see there, we're fixing it back using suitably sized washers and some screws, making sure we've got a good fixing through into the wall there. And it's not going to be falling on anyone's toes because this is quite heavy. I see we're running off here for this thing. I don't know what it does, but it got rid of a lot of the stuff that was dropped into the box there. So yeah, did a decent job of that. And you can see here we've now got everything set into position, ready for some wiring. So we can see I'm just going to start drawing over some cables, and at the minute the final circuit, sorry, the distribution circuit led down to that Schneider board on the main switch. I'm actually going to join that inside that Schneider board and loop it across into this RCD. So basically this is going to be up front of everything else. Didn't necessarily have to do that. I could have just powered it from the Schneider board, but you know, it made more sense for me to have it done this way to try and get some of the leakage current that may be happening naturally on this entire bay to be shown in the display of this RCD, as I'll show you later on. So with these, when you're drawing your single insulated cables through, it's important not to snag them, so take care when you are drawing these through your openings, so you make sure you're not snagging them anywhere, or when you're running them through the trunking that they're not getting any snags anywhere as well, and removing that insulation basically, and you've got a cable that's usable installed. And obviously your testing would prove that before energizing, but you don't want to damage these things unnecessarily. So you see I'm looking for a suitably sized Allen key here, and this one from Klein Tools is brilliant. It's got loads of different options on there. I've got the 2 other sizes in that range, so they start from quite a small handled option up to a large one. This is the mid-sized one, and it just allows getting decent purchase on there to get those cables in and tighten down. Obviously you'd torque them up to the manufacturer's spec later on, but this is a fast way of getting them in there, and it's suitable for a tool bag. I have that in my bag, as you would have seen me retrieving it from, because you know it's great to have in there if you're coming across any Allenstein fixings. You've got lots of options there in your bag ready to go. So you've got the earth cable in there, and I am just looping that across the earth bar in here. I didn't see the point of joining it in Wagos to stay across one place, then bring it back to another. So I've just dropped that in there to earth the enclosure in and of itself. Took that up nice and neat out of the way. We now need to take the existing cable that's coming over from the other DB, the other side of the unit, out of there, and we can join that in some Wagos to run across into the input of that MCCB in the Proteus RCD board. So we're just going to pop those in and start putting our cables in across to that RCD device. Now, I didn't do these all at once because I didn't have any black or grey single insulated cables, so I was running the lines individual to each other, and to save having to mark them and getting mixed up, I've just brought them across one at a time and putting them into the terminals one at a time, so I cannot get them mixed up. This is just my methodology with not having black and grey cable, and yeah, it's a trading environment, so go easy in the comments. Obviously these are only 4mm conductors as well, so they're massively undersized for the purpose, but there is a C16, I think it is, in advance of all of this down at the main panel board, so we are suitably protected anyway. But you know, in the real world you'd have much bigger conductors coming through this, and you would need some bigger openings in your containment, and possibly bigger containment in and of itself to accommodate that as well. So it can look a little bit out of place and different to what you're expecting because of those smaller cables, but we're just getting them in there. It is just to show the features of this product in a training simulated environment rather than real world applications. And that Klein Allen key is absolutely brilliant. I really like it. We use the bigger one in solar quite often as well, just to make our first nip down on some of the fixings we have on those kind of systems too. So my single cables, I'm going to draw up the back alongside the live link lead that runs up that Proteus board. So it comes off the bottom of the MCCB, runs up to the top left corner where it joins into that 2 amp fuse before feeding the RCD. So I'm going to follow that cable route for mine as well. See, we need a little lug here for the earth as well to pop onto the main earth pin down the bottom there. So we get that lugged up and onto the earthing terminal, and then that can be tied away with everything else as well. So we've got some more singles going in. So these again, drawing back the other way this time. I don't know why I swapped round one to the other, but you know, change is as good as a rest. Doesn't really make that much difference. But these are now returning back to that metering kit on the underside of the Schneider board. And it may not be that easy to see on the video, but there is separate terminals for this. So the meter basically has your inputs coming into it, and then they loop across over to the main switch out of the meter. That's just a way to measure what an individual board's been doing. And metering kits are pretty common in commercial environments. If you've not seen those, if you work in the domestic sector training to be an electrician, you might not have come across it before. That's how they work. So you take your feed into the meter itself, and then it loops off and away to that main switch. And that all comes pre-populated in the metering kit from Schneider. So we just need to pop the inputs into there to power the meter, basically. So that RCD now has the main feed into it, and it then loops off from the output terminals off the top here and across to that metering kit to then power everything in this bay. And the reason I wanted to do that was to see what natural leakage was occurring. And, you know, if we've only got one circuit running through it, that's harder to do than if we've got multiple ones. And we're going to grow and expand on this, and I'm going to change the setup in the entire academy to make better use of this, as you will see in the clip following this voiceover. We're going to run through a full test process, both using the built-in function on the relay kit and also using the TIS MFT Pro Plus, as you will see later on. But we're nearly there now, having wired this up, and it doesn't take that long, even having the strip out and all the new wiring going in. I've made quite a bit of mess behind me, and we'll have to deal with all of that at some stage later on in this video, but for the minute it can stay as is. It's just that, as I said, we've got tools all over the place, and it was a case of dragging it all together to get on with what I wanted to be doing here. And you can see there we're just about sorted. We're going to dress these up the side and neaten everything up a bit. Bit of a cable tie base as well going in. For those of you who don't like to cable tie conductors in consumer units and distribution boards, often much of the derating is already taken account of because of the containment leading to and from. See, all these cables are horizontal in that trunking, so they all need to be derated accordingly because of that. And that same derating will aid you inside the switchgear as well. It's a bit of a myth some people like to share around all of that, that if you're bunching your cables inside switchgear, there's extra considerations around derating, when usually it's taken care of anyway in the specification you would use for your overcurrent protective devices and also the containment leading around it. But hey, it makes for an interesting podcast topic and for people to sit on the perch of superiority towards others. In this case here, we're going to have next to no load running through anything anyway, so it makes no difference. I just wanted it to look neat and tidy, and that's the approach I've gone with there, just tying those up. And again, they're not pinched super tight, just holding them in position with a bit of slack in there as well. Pop the trunking lid back on, and we can start to have a look at energizing all of this and getting on with some more useful testing and investigation of what is a pretty cool product. So you will have just seen me putting together this little RCD unit from Proteus, and I've tagged this into the booths over in kind of what we call the commercial industrial space, where we do some of our containment and messing about with circuit testing at 3-phase. And I've just powered this temporarily, so this is now fed directly from this big Proteus MCCB panel board. It comes over and it's joined in Wagos at the bottom of this Schneider board and just looped across and in. These aren't color coded, so your phases, I've not tagged and flagged them up as the brown, black and grey. However, this is just temporary, so these aren't going to be staying here. It is really so we can power it, have a look at it, see how it works and operates, and then it's coming out to go in the college drops off to a training provider so they can use it with their students. We're going to get another one here for ourselves as well. So at the minute, we've got it coming off, I think it's an RCD module as well. So yeah, it's a C16 that comes over, and it was into this Schneider board just to give us some 3-phase power here to do what we were doing. But that now loops straight across into this RCD. It comes in the bottom here, so as you will see, if I get out of the light, we bring in all of these conductors, so it's our neutral, L1, L2 and L3 through this big CT clamp. Obviously this is quite large because we're supposed to be 160 amps, and you can get these up to much bigger sizes than that as well. And then on the output side here off the top, you can see we're running off to our final circuit, which basically is now this Schneider board. So it comes into the bottom of this metering kit, and it's now going to run this board, which basically is a socket over here and a socket over there. So there's not a great deal going on this. It is really just the training space, but it will enable us to have a look at this. Now you can see off the bottom of here, we've got a line and a neutral running into the side of the MCCB here. Now those tie away and run off to this RCD monitoring module here, and that is where we can make settings for what we want our RCD trip currents to be and how they behave. And in essence, when that sees some earth leakage, it can operate this MCCB. So you can see there's a couple of fly leads running across the top here, and they drop back down into this as well. So these are taking power off to this actual unit to power it. it's looking at what's going on through the CT, through these comms cables that you can see here. So they tie into the CT itself. They run off and away and into the top of these here. So you've got 4, 5, 7, and 6. And they drop down here to 4, 5, 7, and 6 as well. And that communicates with the CT clamp in and of itself. If I can get down the side there, you can have a look at what it says on the side there. So that's basically giving you the spec of this CT. So it's 30 milliamps, 1 to 1.5 amps. So you can change it in this here, and we'll have a look at that when we've powered it up in just a minute. You can see we've also got a little fuse up here. So that is bringing power down into the bottom of this as well. So it is fused and protected. So the main line feed, if you see it running across at this side, the line's going up this side, around there, into this fuse, and then off from the fuse into power this. So it does have an element of protection itself. If we open that up and have a little look what's inside it. So that is a 2 amp GG fuse. So that's going to sit in there and just look after the RCD element itself. Because what I'm going to do now is I'll pop you back and I will put the covers onto this and we'll liven it up. We've had everything isolated down at the main intake to this area, so none of the DBs here are energized presently. But I can get these all covered up and we can turn it on and see how it looks. So you can see here we get a little instruction sheet that comes with it. There is a YouTube video to watch. I'll link it in the description if anyone wants to go off and see how this is adjusted and played with. But basically you've got a few settings. So you can have 30 milliamps to 1.5 amps on your RCD protection. If you're in the 63 amps to 250 milliamp range, you can have 100 milliamps to 1.5 amps RCD leakage, earth leakage that are allowed to happen at the 315 to 630 amp range. You can have a time delay, but it says here with sensitivity set at 30 milliamps, the time delay is automatically cancelled, i.e. it's instantaneous. The relay screen show you certain bits of information. So the bar graph shows the earth leakage, and you can see it here. If we scoot back out into the main menu, it will actually show you what's going on in the circuit itself. So you can see here at the minute we've got 1.83 milliamps of leakage that's going on. You can press the test button and that'll trip the MCCB. So pushing this button will cause the unit to trip the MCCB after the set delay time. And then the reset button, you have to press that first so you can then reset the main RCD, and we'll show that happening in a minute. There's some other little bits of instructions in here that you get as well with a circuit chart and diagram. You've got your layout and rating there for the low voltage modded case circuit breaker, and then you've got the little instruction sheet here which shows you how the relay works. So if you don't want to watch the YouTube video, you want to pop your glasses on because this is incredibly small writing, it'll take you through how you can program this up and set it up in the way you want. We'll just demonstrate the test, and this will go with a clunk and probably scare me, but if we hold the test button down, you can see there it's tripped and it's illuminated red. So we now need to hold the reset button down. Now that's gone back green, we'll be able to cycle that to the off position and then turn that back on. So that's tested the function and operation of the RCD there. So what I thought might be interesting is now we've got this and we've pressed the test button on it and seen it operate in and of itself, is we'll use the TIS PV Pro Plus to do an RCD test and see what operates. Now I have to say here we do have lots of stage RCDs because I was super paranoid about trainees coming in here, and if we had any kind of fault happening, even down here at the bays, I'd like the power switching off as far back as possible to alert people to that issue. So that's the way I've set it up. The logic to that 2 years in maybe wasn't as needed as I thought it was at the time, but we're here now. I can't change that. So it's what it is. So when we do this test, we may operate this in its own right. We may not operate it at all because something else might see it a little bit quicker, but we'll run the experiment anyway and I'll share it regardless. So if we go into here and our RCD testing, first up, we'll do a half-time test. So this shouldn't operate. If I bring you in a little bit closer, you see this screen, I'll turn it off face track. If it stops wandering past my face, there we go. And I'll position you looking at this. Let's see if that focuses. Let's get this in shot as well, testing my camera skills. So we can see we've got 245 volts-ish between line and earth and line and neutral. So if I hit test now on the half-time test, it shouldn't trip. But you can see here, we did have that jump, the little spike on there. So I'll run that test again, and I'll pay attention so I can at least read it if you don't see it. So that's jumped up to 15 milliamps. So that shows that this is actually doing a good job of the half-time test. Now we'll swing it over to 5 times. So it's going to give us a big old bump in milliamp leakage. So 5 times 30 is 150 milliamps. So it should jump up to that level if I hit test. Now you can see it's done what I thought it would do, and it's taken out the RCDs in advance of this and of itself. So I'll go and reset them, and then we'll try it at 1 time and see what happens with that test. So just bear with me a second, we'll see which one it got. It may be that I end up having to go right back to the other side of the unit. Oh, no, there we go. So it's just got the one over at the main panel board there. So we'll try it again now at 1 times. So this is just going to do the 30 milliamp test. I'll bring you in closer again and get this in shot as well. And we'll see which one takes this out first. You can see background leakage, we've got around 3 milliamps. So if I hit test, and you can see there, this is the one that's operated in there now. So we've had the one go in this board, just to the side here. So we've lost our final circuit here. This one saw it first. Oops, turn the wrong one off. So that's a C32 RCBO from Schneider, which is interesting. So, you know, in the real world of things, it's not how you're going to have this set up. But I've programmed this to 100 milliamps. So that's why I jumped over to the 5 times test to 150 milliamps to see what went first. Obviously, these other RCBOs that are in circuit are 30 milliamps. And I know from doing these experiments before where I've staged RCDs in series of each other that it is very much potluck which one sees it first. Sometimes it's the one right at the source, other times it's the one right in front of you. It just seems to be absolute potluck. So we'll run it once more. I'll set it to 2 times its rating. So this is going to push it up to 60 milliamps, just as a little experiment. And that's taken the one out over there. I heard it go. I think I heard the one go up the other side as well. There is actually 1, 2, 3 RCDs before we even get to this one. No, I just took that one out. So it's interesting. Is what we will do in a future video is I will take the other RCDs out. As I said when I first set this up, I was so paranoid knowing what we were doing here that I was putting RCDs in all over the shop. So if we had any kind of earth leakage or issue, stuff's getting switched off all over the joint. That was by design. It's not how you would do things in the real world. You know, you wouldn't set up like that if this was a proper customer's install. It's the last thing you'd want, that kind of a fault here would be impacting something going on over the other side of the warehouse. You just wouldn't want that. But I did want that. So we are where we are. But that's an interesting test for another day. So we can do that. We can take out the other RCDs. That one over there won't be a problem because it's steel wire armour leading over. And that one over there won't be a problem either because that's steel wire armour. So yeah, they can all come out. And we can still satisfy the intent of BS761. So happy days. Yeah, so that was a nice little test just to demonstrate here. And it was interesting to see how this kind of did see what was going on in terms of that leakage current. So we had it set down to half time, so 15 milliamps. That is exactly what that was showing happen through the test instrument. I do need to take those other RCDs out of circuit, but I don't have time today. There's other things we're on with, and it would involve stripping quite a lot of this apart. But I will do it. We'll come back to it before I move this from the bay and show it in some of the short form content maybe. So keep your eyes peeled for that one. Let's move on with the video. So I thought we'd have a little look at this now I've had a tidy up and clean up. I'll show you around the other side of the camera to prove that I've done that. Always ends up a bit messy in this space when I set to, because I'm pulling tools out of different bags we've got dotted around the place here, depending on who's been doing what and when. But I have had a full reset and sort out. But coming back to this, I just wanted to talk about the way this actually operates. So it is kind of 2 different component parts within this enclosure. You've got your MCCB here, which is the 160 amp variant here with massively undersized cables, it has to be said. And that is looking for your overload and short circuit faults. So if you get end of line and neutral touched together, it's going to be this that sees that and operates. Same if you have a consistent overload, something's going on in the circuit. You know, we could end up putting loads of different final circuits out of this distribution board here, and the final sum total of all of that draw operates this. The RCD relay element is what's looking at those electrons flowing through the CT clamp. So you have your line conductors and your neutral conductor, and basically they want to see the electrons that go out into the circuit come back and return through it as well. If any of those go missing through an earth path somewhere, this sees it, depending on what you've set its limit and tolerance to, and operates the MCCB to open that circuit as well and return it to a safe state. Now this is, these are both actually rated to 60947-2, so they're not an RCBO British standard in terms of the way the regulations of things understands them. So my understanding is if you were using this, and I might be wrong and Proteus can correct me, but that would be a deviation in RCD protection through the regs. There's going to be way smarter minds on mine than that. But there are other options available off the shelf, and this one's from Proteus here. This is a single module RCBO. So bring this in a little bit closer. Have a little look at that if it will focus. I think it's focusing on my head. So I'll put it right next to me. But basically this is also a type B. So this is type B, single module RCBO, and this one's rated as a B40. It's 30 milliamp and it's 10 kA. So this is kind of fixed in its values and settings and the way it operates. But it does have the product standard, or the British standard, of 61009-1, which is what we need for our RCBOs in terms of the wiring regulations. So there are those options off the shelf, and obviously this is going up to the 100 of amps, and you can scale it as well from 30 milliamps all the way up to the 1.5 amp range. And as we discussed in the video, those are all adjustable and settable depending on the size of your MCCB, basically. And there are applications where you're going to have selectivity in your RCD protection. And I know from speaking with Neil Bridgman and the challenges he faces on the railway sector, for example, where your source RCD protection might have to be 1 or several amps rather than 30 milliamp rated due to selectivity as you move through those circuits. And these are a great way of achieving that. And there used to be a standard in the regs that escapes me now for those kind of combined RCDs. You know, you have your 61008, 61009, I think it was 42 something. It's escaped me. But there is another standard there that used to account for this that has now been removed from the regulations. So it'd be interesting to see what you think in the comments around this. I'm going to ask the Proteus team, because my view would be that if you're using this kind of setup, it would be a deviation from BS 7671 as it stands today. But it's an interesting one, which is why I've mentioned it in this video. I'm going to spin you around and show you around the workshop booths and show that I have made an effort to tidy up. So you can see this floor was littered with stuff because I've been bringing bits and pieces through. We've had a clean up in this area here. So we've still got our, this is kind of where we've got all of our EI and C stuff. So we've got all of our relays, fuses. I've shown a video on this before, and this is still waiting for someone who knows more about this kind of stuff than me to finish off. So hopefully we get there with that at some stage. I have brought some other final circuits into this space that are living up in that box. So I've made some tweaks and subtle adjustments to that, but there is things that are coming there. This one here we're kind of using to demonstrate contactors and how you can switch and change different things to happen using them with key switches. And we've got a little light here, which is just a basic illumination of what's going on with the contactors. So we've got both single phase and 3-phase ones in there because this is a 3-phase board. If I can open it. And again, you can see we've got these are our RCBOs in here. This is a normal 3-phase breaker. I'll run through all of these because it might be interesting in some content for the trainees out there to understand what all of that does. We've got our tails isolator down there. This is kind of to replicate a 3-phase setup. But all of this is protected at multiple layers with RCDs. I will have a chat about that before I close this video out. We've got some of the old switchgear here, which was sent in bulk by Burn Electrical ages ago. I've added a few bits and pieces along the way, but that just demonstrates some older switchgear. We've also got our BG Sync EV charge point. That does actually work. It runs off this little board here. And again, we were using some of the contactors the other day actually to demonstrate switching that on and off, which was interesting. This kind of space here is to set out what you might find at a main intake in the traditional sense with your Glasgow switch and busbar chambers. So we've got that set up there. We did have some final circuits into that, distribution circuits into that not too long ago, but it's all been stripped out, ready for someone else to have a go, basically. This is the original isolation point for all of the booths, but that's since been superseded by this. So we're waiting on a supply upgrade down to this area still, once we get the DNO sorted out, but there is going to be a bigger supply coming into this building for other super secret reasons, but that's all set up there, ready and waiting to go. Basically all the way over there is where our intake currently is, and we come and track round, if you watch back to the video when we first built this space a couple of years ago, and feeds into this. But once we've spun that around and the supply's at this side, it's going to go the other way basically. We won't have to change much in the way the final circuits are all wired, but the distribution will be from this end of the building, and this is all kind of input here ready for that. I am super paranoid, so we've got RCD protection absolutely everywhere. You'll have seen when we were testing this that it's a bit hit and miss as to what kind of goes first, because that's an RCD in and of itself. And it's also sat running through an RCBO in this board, or maybe both those boards actually. And then right at the intake over there, we've also got an RCD in it, and they're all 30 milliamp rated. And the reason being, I was super cautious knowing that trainees and learners were going to be in here. And if something went wrong, I wanted as much of the power taken out as possible to alert people to that, so we could do something about it. You know, it's doomsday scenario because no one's ever unsupervised. I've never had an issue, but it's just the way I thought about it. And, you know, in hindsight, maybe I was a bit too cautious, but that was my chain of thought at the time. This area in here, again, we messed about with containment. We've taken a few bits out of late, but we do like little bridging exercises to get past obstacles. And we did have all this trunking extended down across here and coming out onto the floor space for a pillar that was up there. It was in the way, so that's all gone. And yeah, we often run little tasks. You see up there, we've got the solar array. There's all this unistrut across here, so we do little trapeze stuff and hanging stuff off there, so you can set out with your drops for other types of containment. We've done bits of that in here before as well. And it's just trying to simulate stuff that you might find out in the real world. You can see we had an accident at work. That was on the RIDA report. So this unfortunate colleague got squashed when some containment fell on him, and he's been sat up there ever since as a very clear reminder to work safely. So that's that. I'll spin you back around. Figure out how to do it on this camera. There we go. So I hope you have enjoyed this little bit of content. The real aim is to just try and increase some of the knowledge that trainees maybe aren't getting out in the industry of things with their training providers or their employers by sharing interesting things like this. It's not super common to find this out in your everyday installation work. It is kind of bespoke to industrial, your railway environments and such as well, where you will have these staged RCDs. So if you're out there in the world of domestic, solar PV, normal commercial contracting, you've maybe not seen this. So I hope it has been useful. I'll drop links in the description over to the data sheets from Proteus for some of these products, so you can go off and check them out. And if you've got any questions or anything I've omitted or not mentioned, please do get them in below. You'll have seen from the voiceover that I dropped a few little gremlins in there in the way that I approach this task from memory. I think I did a little clip of drilling into the box without any kind of drilling into this without any protection of the swarf, dropping in and amongst everything, and also into the trunking, snagging some of the cables as well when you don't put your protection in there to stop and guard against that. You know, and what I was doing here, it didn't matter because all those cables were coming out, and you should never be working in and amongst live cabling when you are doing stuff like that. But you will have final circuits in containment where you have to make entries to them, and you always need to try and get your cables out the way and protect those. Even if they're de-energized, they get snagged in the drill, they're going to pull, they're going to rip, you're going to take the insulation off, cause yourself an absolute nightmare. And worst case, if you have a cable in there that's energized that you don't realize is there, can cause you a catastrophic injury. So make sure you are careful when you're making holes into containment. And I shared a little bad example of that through the course of this. Otherwise, I think I've waffled on quite enough about this, so I will leave that video there. Please do drop your comments in as always. And like I said at the start of this video, if you haven't yet, subscribe to the channel. It makes a big difference of trying to share this out. I do try and drop content in and amongst all of this that is helpful to trainees, which is what this primarily is, and a bit of information around the product you might not be familiar with, alongside the solar and normal electrical work. Try and get a big range out there. And the whole aim of that is to share what I achieved with my sons, so I can look back on in the future at that. I think that's super cool. I'm not looking forward to being old, but I'm looking forward to having a record of what we've done. Also to help industry, so the ad revenue that comes back through this channel, I use into Apprentice 1-to-1 to help try and improve standards out there at the coalface of contracting. So any help you can give just by simple subscription to my YouTube channel would be fantastic. Otherwise, I'll see you on the next one.